Yeah. So straight to yeah. I said my name is Oluwaseola, but by name I'm one of the leaders in Creed, and Creed is just C stand for Christians, the next R stand for redeem, the next letter E stand for equip, the next letter E stand for empowered, and the last one stand for destined. And it's into 4 perspectives. We look at idea incubation, we look at talent development, we also look at entrepreneurship, and we look at employment. Not that we give job, but we do have some of our elders in church who is into that area. And we also talk about academic excellence as well. So our own role is to look at what can we do to empower ourselves, that we're here in this city is not by mistakes. So can we identify some skills to upskill ourselves? And we're so fortunate that in the church, we have a whole lot of resource persons. And one of them is Mr. Kule Polati, who has volunteered to teach us this data analytics for free, which is really actually some, I must say, some people would like to collect £1,000 from us per each person, but he has decided to teach us for free. And one of the things we want to beg us, we should not take this free class for granted. Let's be aggressive with it. I'm sorry to use that word, to see how well we can practice it, not so that it should be on CV. It should be what we want to go and practice. We should identify. I read something on NHS or some 4 or 5 months ago that they have a challenge with their data stuff, and one white guy volunteered to help them, and I know definitely they're going to employ that guy. So we want us, what we are going to learn, to go and be like a hunter to kill the lion. Now, what we are expecting that in every of your field you find yourself, go there and use this what you have learned to help those whether pastors or ministries or agencies. You can start with a charity, work with and help them fix their problem. And the way that we need to apply for jobs will have reversed, because they see us as talent, and because the goal at the end of the day is that Chris should be like a talent city where people would demand. We have a lot of talent, and even ability to even see the future as well. So not to waste time, I want the time now because I really want us to keep the time today. So we have 2 minutes. Can we have a brief introduction, all of us? Can we just, what do you expect in this program? But whether it's only 3 of us that are able to introduce themselves by 1:05, we start. So can we have people who just introduce themselves? What do you learn? Just introduce yourself one by one, all of that.
Hello, everyone. My name is Damilola. I'm in the University of Aberdeen. I am currently doing my MSc in Information Technology.
Thank you very much.
Thank you so much.
Hello, everybody. My name is Olusheye Oligide. So I just got into Aberdeen August. My wife is the one who is schooling. I'm an internal auditor with, or I was an internal auditor with FCMB, and I'm just trying to upskill myself.
What did you say? No.
Please, can we mute ourselves, please? Okay, Mr.
Okay, so I was saying that I was an internal auditor with First City Money Bank way back in Nigeria, still job hunting. I'm trying to upskill and data analytics. When this opportunity for to upskill as a data analyst came up, I think it's going to be a very good opportunity for me to develop myself further. I have, let me say, 10% knowledge in Excel, because Excel is ever progressing. But hoping this platform will give me the opportunity to even gain further or more knowledge in other areas. Thank you.
Thank you very much. Mr. Kule, it will be your turn now. I want to share good news with us. Data Lab, one of the white guys, will join us one of these days in our program, and so that we could form a collaboration so that what we're learning, they will come to observe us, and that could also be a very easy way to get jobs. So I was informed of that during the week. I met them actually. I met one of them, the leader of the Data Lab in Aberdeen. So we expect some of the white people to come and join our program as observer, and we can never tell what can happen. They may select some of us. They may say, okay, Sean, can you give us one of 5 people or 10 people? Can we check whether they know what they're doing, all of that? So I want us to take this class seriously. So, Mr. Akul, over to you, sir.
Okay, thank you so much. Thank you, everyone. How was our week? Fine.
It was great.
It was great.
Thank God. Thank God. As our usual practice, will take maybe a minute just to, as spiritual people, just to commit today into the hands of God, and also ask God for wisdom and direction, and ask that God's the purpose of this meeting will not be defeated. Can we just do that in 1 minute? Good morning, good afternoon, everyone. Welcome once again. Yeah, last week we were able to try to look at what data modeling is. We talked about the 3 levels in data modeling. The first one, the concept, when you pick up requirements from the client that you want to design their database. And the second level is the logical level. And the last level is the level whereby you do the physical design. And we further went on talking about the physical design, and we talked about the ER diagram. We started looking at how we can design ER diagram. We said ER diagram is a combination of so many entities, and I said entities are what we convert to tables, and where we also said as a take-home, I want us to get a scenario, maybe in our office or somewhere we've worked before, and try to write out a statement in designing a database. And that's where we are going to start today. So is there anybody that was able to do that? Maybe you can just share with us in the next 2-3 minutes. Anybody? Okay, if there's nobody, let me quickly move on to what we have today. So today we want to dig deeper into entities. What entities are, we've talked about that. Entities are whenever a problem statement is given to you to design a database, entities are the nouns that you find within the problem statement. We are going to do another example, 1 or 2 other examples today as we go on. Instance is one record within an entity. And we talked about attributes. Attributes are the columns within an entity. And we talked about identifier. Identifier is what is unique within the entity. So we use the example of, for example, class ID. I talked about matric number. That's what is unique when you are creating things relating to students. So we'll talk more about that today. We'll go into HR and some other aspects and see what we can learn. And I'm believing we are going to learn something very good. And at the end of this class, I'm going to try to split us into group. I want us to do a project, and maybe I don't know when you are going to catch up. Maybe it's going to be a Sunday or something. Just catch up. Just try to do something yourself. And I will try to squeeze out time also so that we'll look at the project. I want us to do something that, okay, you say, okay, at least I've done this before. And that's the best way to learn. Okay, our objective 1 We define and give examples of entity. 2, we distinguish between entity and instance of an entity. We name and describe attribute for a given entity. After that, we are going to distinguish between attributes and the values. And the next thing, we'll distinguish between mandatory and optional attributes. I will talk about volatile and non-volatile attributes. And lastly, we'll close with unique identifier. So let me quickly move. I'm just going to explain the purpose of, we'll talk about the purpose of entity. Why do we need entity? Entity are the ones that later on, when we get into database design itself, programming, entities are the ones that are going to be converted into tables. So we said knowing how to organize and classify data makes it possible to draw useful conclusions about seemingly random facts. Said our technology-rich world produces vast quantity of facts in need for structure and order. So the reason why we want entities, we want to like structure records, data that we want to store, want to structure it in a format whereby it will be easily accessible and information can be kept properly. That's the reason why we create database. So we said we have examples of a school. We need to store data about the student, the teachers, the courses that we have, the rooms and the grades. That's an example. So for every scenario that we see, there is a way we can actually represent it using there is a way that we can actually represent all these things and store it up to form a database. So let me start with, I want to quickly like put icing on the cake that we already know. What's the meaning of database itself? When we say police base, it means where police people are living. A base is where we have people living. So the simple definition of database is just where you store data, and you can't just put the data in any form into the database. You need to structure it. So that is what data modeling is all about: structuring your data and putting it in a form whereby it can be retrieved easily and you can store more data into it easily. That's what data modeling is all about. It's very, very simple if we can get the concept. So, sorry. So we said, what's the purpose of attributes? Now we said, we've talked about entities. Entities are, for example, I use the example that we, let me see whether I still have those examples. So yes. So for example, this is an entity. We have feedback as an entity. All the columns under it, they are the ones that we call attributes. So an attribute tells us more about the entity. These are the things that we use to qualify every instance of an entity. Instance of an entity is the record within an entity. If you don't understand anything at this point, please quickly let me know, and so that I can quickly move back. So we said it's important to learn about attributes because they provide more specific information about the entity, as I've said. Example, let's quickly move on. Because we have a lot to do, I'm going to move on, but I'm going to make sure that we understand it. For things that I see that we can read up later on, I'm going to jump it. So we said in a restaurant, you need to list the individual items on the customer order so that you can calculate the bill. So for example, this is another kind of a scenario. You want to have a database for a restaurant. So what do they do in the restaurant? People will come, they will order food. After ordering food, they pay. As I'm making those statements, all the nouns that I'm making in describing the operation, how the operation goes on within an organization, you just need to grab all the nouns there. That's what you are going to use to model the database. It's that simple. We're going to see it again as we go on today. So we said in a restaurant, we need the list of individual items, items one, that's one table, that's one entity. Of customer, we know obviously we are going to have customer table. Orders is another entity. Bill is another entity. So it is that simple. In building a database, it's that simple. Just get the problem statement, how the organization is run, or how they do their processes. Just write it down. If you can write it down, just pick the noun and you are good to go. That's how easy it is. So we said we are building several sales reports. You must be able to identify a specific report from the list of reports. So let's see. Okay, purpose of unique identifier. So last week we also talked about unique identifier. We say there are some times that we have records that have similar entries, as in similar instances. So how do you, for example, you go to a bank and I work with some organization whereby, funnily, you see someone having the same first name, same last name, the same date of birth. I've seen it before. So how such record, how do you know that his number is A and it's not B? So what do you use to identify each role in a record? What is the best way, the best approach? Best approach is using unique identifier. So we said, what about unique identifier? We said it's important to learn about unique identifier because it distinguishes a single instance of an entry from another one. So it's a very good way to distinguish between one record from another record. Okay, we said in a class, you need to distinguish between one student and the other student. So you can give the student maybe student ID or student matric number or whatsoever. That will be only for that student. Every other thing can be the same, but that unique identifier cannot be the same. So we said, when classifying your CD collection, you need to distinguish between one CD and the other. You know, for example, you have Lucky Dube CD, and it's the same song that is in 50 CDs. So how do I know that? Is CD1 I sold, or CD2, or CD3, or CD4, or CD5? One of the ways I can know is by actually giving the CD collection ID, CD001, CD002. They have the same content, they have the same size, they have all the attributes, they are exactly the same. But the only way you can say, okay, this one is different from this one is by giving it an ID. That's what IDs are used for, okay? Yeah, identifying purpose. So we want to use, for example, whenever you see like this check sign, you know it's Nike. Whenever you see some signs, these are ways that you identify things. So let's talk about entity definition. So we said sometimes a significance of, something of significance to the business about which data must be known. So we said it's a set of similar things. I use the example of laptop. My laptop is different from your own laptop. Even though, you know, all laptops should have a screen, all laptops should either have a keyboard, which is attached to it, or a screen keyboard. So these features are the same, but they are not exactly the same laptop. We have two different laptops. So the name that is used to group a set of objects together is what we call the entity. Student. I am a student, you are a student. But what's the difference between, the reason is because we are going to a school. We have a common attribute. So what brings together a set of objects is what we call entity. In programming, they call it class. But in SQL data modeling, we call it entity. When we move to SQL programming, this one is data design. When we move to SQL data programming, it's going to change from entity into tables. Attribute is going to change into columns. Instant is going to change into rows. We are going to see it, at least we are going to start programming today. That's our target. So we said usually a noun. They are usually a noun. Say, for example, they are objects, they are events, they are people. Entity have instance. Instance is just a record within. We said an instance is a single occurrence of an entity. So, for example, let me see this one. So we have this particular entity. So if I convert it, I want to convert it into a table. So I will have an ID, this ID, feedback details, I can have something like this, feedback type. It depends on what I want to store there. I'm just using this one as an example. Feedback taking, yes or no. Feedback date. I might put a particular date there. So what I'm doing here is this particular row is a single entry. And this particular row, each one of it is an instance. That's what we mean by an instance. Each one of it. They are the same, but I'm just using that as an example that each one of the records is called an instance. So we said an instance is a single occurrence of an entity. So we add examples of all these ones, different instances that we have single records of them. Okay, so I've tried to explain the difference between an entity and the instance. Say, for example, we have Dalmatia, and we have a Simisi cat. We have a car, we have a cow, we have a pig. All of them, they are instances of animal. So it's just a group name that you can give to a set of object or things. That's what we mean by entity. So one particular one is called an instance. So we said, let's quickly move down. We said it could be tangible, it could be intangible, like skills. Skill is a noun, but it's not tangible. Tangible, touchable, feelable. It could be an event also, concert. So it can be tangible, it can be intangible, it can be an event. So those are the things that you look out for when you are trying to pick your entity. So they just went solo here. I'm not going to do all these ones. What are attributes? We said it describes an entity, qualifies an entity, it quantifies, qualifies, classifies, and we have talked about that. It gives more description to an entity. That's what an attribute is. And these are columns, like the example I showed. So for example, feedback table, you have the reference ID of the person you are putting the feedback of, the feedback details, the feedback type, so all these things, they are just describing what the feedback table is. So they are all attributes. Please, at this junction, I want us to take off our mics. Is there any question that you want to ask at this junction before I move on? Is there anything unclear? Please, can you unmute everybody, please? Any question at this junction? Any addition, any subtraction, anything that you feel I should have said that I didn't say that you want me to shed more light on?
Okay, I want to ask,
Yes.
I was trying to, in the assignment you gave us, I was trying to draw out the entities
Yes.
that is involved in that organization. It's a clinic.
Okay.
And then we have the MD. Then we have visiting doctors.
Okay.
We have nurses.
Okay.
Pharmacy department is there.
Okay.
We have a small IT and patients. So
Okay.
in this kind of setup, how do we not develop their attributes?
Okay, for example, when we talk about departments in that particular hospital, how many departments do you have? And what are the details that you want to know about the departments? Maybe department ID. You might have physiotherapy
But
department.
it's not as big as having those ones.
Yeah, okay.
Like a clinic, just have where the MD consults, then patient stays, and where they receive patients and nurses.
Yeah, so it depends on the okay. When we go on now, you are going to see what's going to determine the attributes that you are going to put there.
Okay.
So what we determine is what you want to capture as an organization. What are the information that you want to capture? In the department, you want to know the department's name. You want to capture the people that are working in the department. You want to capture what else about a department? The location of the department. Maybe you have maybe that particular company has, or the organization has department in different locations, things like that. So it depends on what you want to capture as information. That's what is going to determine the attribute. You know, attributes is just describing the entity.
The entity, yes.
Yeah. So what do you want to capture as an organization? So what an organization can say department, they just want to capture the name of the department and give each of the name an ID. Another organization might say they want to go further. They want to put location, they want to put so many other things. So that one is solely dependent on what the requirement is all about.
Okay.
Do you understand?
Yes.
Okay, any other question before we move on?
Sorry. So from the last speaker's example, so can it be safe to say probably what they would want to capture would be probably people that visited the clinic in the past, let's say 1 month?
Okay. So that people that, okay, from what you have just said, people that visited the clinic for the past 1 month, what are the nouns? The people that visit a clinic, they are called patients. So you carry that patient, yes, that visited. That's a relationship. Yeah, that's a relationship. They visited, time that they visited, date or something to specify the time. And what else?
Then cases, probably their complaints or
something. So these are the things that you are going to like build on. For example, patients, what do you want to capture about the patient? The patient's name, first name, last name, address, and things like that. You understand?
Yeah.
For if you want to talk about the cases or the kind of sickness, you might have an ID for the sickness. You might have the type of sickness. You might have the type of symptoms of the sickness. You might have whether the sickness is a sickness that will be treated or the one that will be managed till the person dies. Things like that. Those are the things that you put as your attributes to like manage that particular database.
Okay.
Yeah. Okay. Any other question?
Yeah, Rakule, thank you so much. So this is Cyril here. And hello to everyone on the call. I have a quick question on defining what are your non-negotiables, because I'm a bit worried that once I'm designing a Excel database and I have my entities defined, and there's a change of scope. For example, management says, "Oh, we don't want to see this, but we want to see that."
Yeah.
How do you manage a change of scope? Because it may be crucial. Correct me if I'm wrong. It may be crucial to everything we are doing here.
Yeah. So very simple. Changing the scope doesn't mean you are destroying the whole database. It means that you are just adding one or two or other entries into it, maybe entities into it. So what you need to do is, we are going to go into another, I think the next few slides now, we are going to go into how do we manage relationship. So relationship within the entities is what we are going to use to build on database. Database actually grows. It's not static. It depends on, for example, when we started banking in the olden days, banking, you have limited type of accounts, savings account, current account. Now we've had more than savings account, current account. We have different kinds of accounts now. So in such places, will you now destroy the database? No. Those savings accounts and current accounts still exist, but you have additional things that could be done with that could be registered on your database. So you can fledge it, and we are going to see how we are going to do something like that. So it's not something undoable. It's even part of, that is the major reason why you actually need data modeling. You can actually go and just design a database directly without modeling it. Some people can do that. But when you do your data model, you know, okay, this is where I should fix this one. This is where I should fix this one. So by the time you are taking it to database administrator, you will see, okay, these are the new ones that just came in. He just writes the script and add it to it. So the person just changes it to, like, for example, while I was trying to design this, I and Pastor Ejide, he gave me some requirements. Sorry, let me remove this guy. He gave me some requirements. Later on, he increased the requirements. All what I need to do is just to add the additional entity to it, and I wrote the query to do it. That's how it works. It's incremental. It's not something that is static that you can actually work on or improve on.
Okay, thank you.
Yes, so okay, any other question before we sum up? Okay, if there's no other question, that means I can move on. Yes. Okay, we've talked about attributes extensively today. What are attributes? They qualify the entity, they give more meaning to the entity. That's what attributes are. And we want to talk about the data type. What does data type mean? Data type means how the data is stored within the attribute. For example, if you have an entity called customer, how will you store the family name? It will will not be numbers now, Abby. It's going to be strings. Do you understand? So it's going to be string. They call it VACA as we go on. VACA is called strings. It's combination of alphabets and numbers, special characters, and the likes. How do we store date of birth? The data type is called date. How do we store numbers? Shoe size. Shoe size is numbers. How do we store town of residence? Email. Those ones are VACA, they are strings. So the type of data is called data type. Type of data type is just how do you represent this attribute within the database. That's what data type means. Okay. So we've talked about example. I don't want us to take so much time. Okay, let's talk about okay. We said some attributes such as age. I talked about this last week. We said have a value that is constantly changing. It keeps changing. So we call them volatile. You know, volatile means something that can change form. Volatile attributes. So we said such attributes such as order date will rarely change, if ever it will change. So that's why we said in place of age, why don't we use date of birth? Why? Because age is volatile, it will keep changing. But when we use date of birth, it's much more stable, non-volatile. So in database design, it's better you use non-volatile attributes to store records. That's a better design of while creating a data structure. So we say, for example, using date of birth instead of. So if you are given a choice, select non-volatile attributes, which we explained last week. Okay. So we said some attribute must contain a value. When it must contain a value, we say it's mandatory, it's a must. We'll still talk about that more. Say, for example, in most businesses that track personal information, name is required. Name is mandatory. So we said other attributes may either contain a value or be left null. So later on, when we start talking about SQL, we'll talk about null value. some columns, they can accept no value. That means you can leave it blank, not compulsory. Whenever we are filling a form online, they will say this particular place, the asterisk it red. Those ones are mandatory, because at the back end, they will have set the database also that if somebody does not put this thing, it should reject it. But there are some part of the form that if nothing is done, it will still allow it to be imputed into their database. So we said, for example, cell number is often optional except mobile or wireless application. So for example, if different things can be mandatory somewhere, it might not be mandatory in another table. So it depends on what the focus of the organization is. That's what is going to determine whether a particular column or attribute is mandatory or is not mandatory. Okay, let me move on with speed. I've tried most of the things I'm trying to jump off, explaining one time or the other. So I've explained what unique identifiers are. I said it's used to identify a particular kind of object. Okay, I think that's all. Let's jump to the second. We have a lot to do today. That's why I need to move a little bit fast. But if you have any question, please don't hesitate to ask. Okay, so we want to talk about ERD. So we said, first and foremost, what does it mean to be implementation-free model? Implementation-free model means that no matter what kind of database that you are using, your model should fit in perfectly into any kind of database. And that's the kind of, that's what ERD modeling is all about. Entity relational modeling. So we said a good conceptual data model stays the same regardless of the type of database system. And that is what makes it an implementation-free model. Okay, so let's go on. That's what they explained there. What is an entity relational model? So we said it's a list of entity and attributes, as well as all relationship between the entity and the attribute and their importance. So basically, we want to now go deep. Okay, how do we now design this entity relational model? Let's quickly go into it. If there's anything I need to explain, I'm going to try to explain it in details. What's our goal one? We want to capture all data requirements. You know, I've told us last week, first thing is conceptual data modeling. You get the concept out. Conceptual data modeling is writing English. You just write down what the person wants. That's conceptual modeling. That one doesn't need any big thing. The next level is the logic. How do you group them? Creating the different entities, picking the noun and trying to look at how those nouns how they are related. And the last one is now creating the physical model, which is the ER diagram that we are going to still go deeper now to see how we can create it. So we said our goal is to capture all required data to ensure that data appears only once. So one of the good things about this doing data modeling is it does not give room for duplicates. You will not create an entity twice if you have already done the design, because obviously you see it from there that this one exists twice. So there won't be room for that. So we said also the third reason why the goal of this particular entity relational modeling is it helps to derive other data already modeled. So last week we talked about address. We said any attribute that could have attributes, automatically you pluck it out from the model. You use it to design, it becomes its own entity and you give it its own attributes. So that could only be possible when we are gathering information. We won't be able to say, okay, this one will be converted to an entity later on. But when we start designing, we will now see that, oh, this guy, because it's going to store records that are like this, you pick it out. As at that time, you'll be able to like see it holistically, and you'll be able to design it properly. And the last, but not the least, and so many other things you can actually be the goals of AI modeling. But the last one here is it makes you to predict how the data is going to be structured. Okay, so that's what they try to explain here also. So let's look at a real life scenario. So we said, I'm managing the HR department of a large organization. I need to store data about the company's employee. So help me out. I want you to unmute now. Let's look, you tell me the nouns here, and we'll pick them. We'll see whether we are right. So we'll pick the customers and the company's employee. We need to track each employee's first name, last name, job, position, hiring date, salary. For each employee on commission, we need to track his or her potential commission. Each employee is assigned a unique employee ID. So who can help us and tell us the entities here, the attributes here? Can anybody help us out?
Employee.
If the
Employee first name and last name.
Yes.
What are they? Position.
Yes. Yeah. What are you mentioning now?
I'm mentioning the attributes, with the entity, sorry.
Okay. I want you to,
employee is the entity.
Yes.
First name, last name, position, those are the attributes.
Perfect. Perfect. You missed one more. There's
another one, commission.
Employee code.
Commission. Thank you very much. And one more.
Employee code.
Unique identifier. Thank you so much. So I think we are getting the gist now. Okay. So
can I also ask if you can make the HR department an entity also, because possibly in future you could link the information with HR with administration or IT or finance.
Yes, HR department is going to be since we are okay. Please go ahead.
So I think if HR department will just probably be like, because the information each department will need will be different. The information the finance department will need will be different from that which HR will need.
Yeah, I know that. I know that the string of my question is relatability, right? Building relationship between what's in HR versus, let's say, what's in legal, maybe what's in another department for the same employee. So on that basis, will HR, or can I design the database such that HR is also an entity? That's
okay. So based on requirements, different things can become totally different things. Here, we are creating a database for HR. So HR will be the name of the database. But the one you are explaining now is you are trying to create a database for the whole organization. I think someone is talking. Hello?
Hello, sorry, no. I'll just...
Okay, so the one you are explaining now is, okay, you are looking at the entire organization. When you are looking at the entire organization, if you want to get records relating to HR, you can actually have tables for HR. You can have multiple databases that are linked together. We can link multiple databases together. You can have everything together inside a single database. We are going to see something like that when we start designing the database itself now. So all these things, there's no one way to do them. It depends on what you want to store. You know, that's why I try explaining that database is where data resides. So data modeling is you want to structure your data in such a way whereby it can be a functional information port for your organization. So the way it's going to be functional for me might be different from the way it's going to be functional for you. You might not need some information. I might need the information. So me putting it inside my database as HR department, and you not putting it as department and using it as a database name, doesn't mean any one of us is wrong. Or what we need to understand is, okay, which kind of data do I need? That is what is going to that's what's going to determine how your design is going to look like. Did I answer your question?
Yeah, I think the question is well answered.
Yeah, thank you.
Question is well answered.
Yeah. So the scenario continues now. We said our company is divided into departments. Each employee reports to a department. For example, accounting, sales, or development. We need to know the department responsible for each employee and department location. Each department has a unique number. Some of the employees are managers. We need to know each employee manager and all the employees that are being managed by each one of them. Who can help me? The entities there and the attributes. The entities first.
Entity, department.
At the department.
Thank you very much.
Yeah, the department, yeah.
Yeah. And what else?
And then the department's unique number.
Is what? Is it entity or attribute?
An attribute.
No, it's an attribute, sorry.
It's an attribute, thank you. And what else?
Location, department location.
God bless you. Department
Accounting
location.
says.
Yeah.
Those are attributes to the department.
You said?
Accounting says.
Yeah, accounting.
Attributes to department.
No.
No. Yeah, entities.
No.
They're like sub-entities, yeah.
No.
The entities.
No. The instance.
Instance, right.
The instance of the department.
Instance of a department.
Yes. So one of the department name is account department. So it's an instance. It's a record within. Do you understand?
Okay.
Yeah. So what else? We have one more. But it's tricky. Let's just
employee.
Location.
Yeah, we have talked about location. One more.
Manager.
Employee ID.
Manager.
Some are managers, yeah.
Manager is entity.
Manager is going to become entity later on. I'm going to show you how it's going to become entity later on. Yeah, it's tricky, but let's see. Okay, let's see whether we have done well. Yes. Okay. I'll tell you why we have to break it this way. Okay, see, employee, we have the ID, we have the first name, last name, hire date, salary, commission. Forget about all these things. I'm going to teach you how we got to all these things and how it got broken down. You know, job is meant to be under this one.
Yeah.
But remember what I told you about whenever
We have
it can have its own attributes, we block it out. So job will have a job ID. So for example, in a company, somebody can be the BI analyst. So we can have 5 BI analysts. So which one is which? So that means BI will have, that means job has its own attributes. That's why we need to pluck this one out. So we said from the description, if you go up again, we said, did we miss out anything? Okay, so we said we want to track each employee's first name, last name, job, or position. Yeah, so job is meant to be an attribute to this one, to employee, but because we said we want to track the position, we want to see the title, we want to see the maximum salary and things like that, it will be attached to job. You can't attach maximum salary directly to employee. Do you understand? We are going to see how we did it. Okay. For example, when you have employee salary, employee records, if I want to put this one, I want to convert it to a table. can I write that your maximum salary is this? Your salary is your salary now. Do you have maximum salary, minimum salary?
No.
No.
You understand?
Mm.
But a job ID could have, okay, BI analyst, they can be paid between maybe 3,000 to 8,000 pounds, minimum, maximum. So that has made job to become an entity because it has its own attributes. Do you understand? So that's why we plucked this guy out. So let's now look at the relationship. What's the relationship? Employee works in the department. Department is responsible. So all these names, they are not names that are standard names. Employee belongs to department. You can change the relationship to belongs to. Do you understand? We just want to know that there is a relationship between this table and this table. That's what we're talking about. So the names doesn't really matter. So an employee who is a manager is manages another employee. So why this crop fruit? We are going to see all these things. I'm going to explain it in details as we go on. So you remember we said something about location, the street and things and other attributes. And we talked about location. Normally, country should come under location. Region should come under location. But for some organizations that are globalized or that have branches all over, you have a country name, a country ID. So a better database design will remove country for me. So for example, if you want to say, okay, I want only employees that are from this particular country. When you go into location, it's going to be modeled up. So that's why they brought this one out. We are going to see how they did all these ones. And the same thing they did for region. But if it's a smaller organization, location, under location, you can have all these ones. So this still boils down to how big or how the organization is being run. Do we understand it? So let's see. I think that's all for this slide. We are 1 hour gone already. Oh my God. Let me try to speed up. So let's see relationship. How do we create relationship? Let's start with if you have a child, a father and the children, the relationship within a father and the children, a daddy and the child is father-child relationship. So the father will be, the relationship of a father to a child is father. The relationship of a child to the father is child. So relationships is just talking about how does these two entities, what brings them together? That's what relationships all about. So let's see how we look at relationship in ER diagram. So relationship sometimes, relationship represents something of significance or importance to the business. So how is it important? So showing how entities are related to each other. Two, exist only between entities. So relationship does not exist between attributes, it exists between entities. So we said they are bidirectional. They are named at both sides. They have optionality. They have cardinality. I'm going to explain what that optionality means. It means a relationship can be a must or a may. And cardinality means a relationship can be one-to-one, one-to-many, many-to-one. If we have a many-to-many, we need to break it down using normalcy rule to make it one-to-many. Let's go on. Let's see how we can do all those big English that I just explained. So what is optionality in a relationship? So for example, whenever you want to pick, you want to check whether the relationship between two entities, whether it's optional or whether it's mandatory. you just pick one entry within the two entity and see whether it answers to a must or a may. So for example, every employee, Olapinle is an employee of a company, must have a job. If I don't have a job, if I say may have a job, that means I might not. That means I'm not an employee. But you know, the real situation of an employee to a job is that it must. So that's a mandatory one. But a job, accounting job, may be done by Kunle. So if I don't know accounting, even though I work in the company, I will not do it. But somebody else can do it. So that relationship from job back to employee is a may. So remember we said it's bi-directional. Employee to job is a must. Job to employee is a may. So let's see how we do that. That's what relationship, that's what optionality means. Optionality means whether a relationship is mandatory or is optional. Cardinality. So we say cardinality measures the quantity of something. So the same way we use for optionality. How many jobs can one employee hold? In a senior environment, one employee will hold only one job. That means the relationship of employee to job is 1 to 1. So let's turn it the other way now. How many a job can be done by more than one employee? So for example, BI analyst, you can have 5 BI analysts. So that would be 1 job to many employee. So that's 1 to many. Do you understand what I'm saying? So we usually look at it from 2 directions. So that is what cardinality is all about. We are going to do an example of it as we go on. Let's see an example of it. Okay, so we said, how do you know it? We said each employee must hold only 1 job. That's optionality that we're talking about. Each job may be held by 1 or more employees. That's optionality. So another example is a product must be classified by one only product type. A product type can have many products. So let's see, how do we do this in our relationship diagram? So we said each seat may be sold to 1 or more passenger. If it hasn't been sold, it's a may. But if it has been sold, the seat belongs to a single person. So different scenarios will determine how you look at the optionality and the cardinality. So let's see this particular example. Let's see how it's being represented. We said in a restaurant, a customer walks up to the counter and places the order. Said the customer may order for himself or herself only, or for himself or herself and others. So for example, a single customer can go and order for 1, maybe a meal. And the person can go and order for 5 meals. So in such cases, we'll say the relationship is 1 to many. And a customer must order. Before you can be called a customer, you have to get an order. So it's a must. But the order number 001 may belong to customer 001. It might be customer 002 that actually ordered for it. Do you understand? One order can only belong to 1 customer. One order cannot belong to 2 customers in this business scenario. So let's see how this is shown in our diagram. So, for example, Linda made these two orders, order 100 and order 002. Mill made only one order. Christian made only one order. So we said the customer places order, optionality and cardinality. We want to now use our optionality and cardinality. Optionality means maybe a must or a may, while cardinality means one to many. So we said each order must be placed. You can't just do an order when the customer has not requested for it. So must be placed by one and only one customer. So this order 10 cannot be done by Linda and Neil. It can only be done by Linda. You get it? So each customer must place one or more orders. So Linda can place 2 orders. Neil can place 1, can place 2, can place 3, can place 4, can place 5. But he must. So how do we represent this in our ER diagram? I think I've explained that. Let's go to how it's going to look like in the ER diagram, the next slide. Don't worry, I'm going to take time to explain it. Okay, before we do ER diagram, we talked about different signs. These are signs that we see on the road. Why do we need signs? For every language, there is always like a convention, a way that you speak the language or you write the language. So let's use our HR scenario again. We can remember the HR scenario. So let's quickly go to our HR scenario. So we said employee, one employee. So let me use this to explain. So one employee, this is how the ER diagram, this is how it starts. One employee must belong to a department. So one employee, one, that's why the arrow is just one arrow, must belong to a department, one department. One department may, dotted line. When you say dotted line, it means may. Have multiple, this one should have a crop fit, or because I'm not using the ERD diagram tool, I don't have crop foots in this one. It's a must. So when you combine the two together, these two together, you are going to have a thick line and one entering here. A dotted line is going to change to, let me see. So you create the two of them individually, but later on, you now combine it together. Sorry. So while combining it together, while combining it together, the direction takes priority. So this will be converted to dotted line. Why? Because it's coming from department. This will still be all employee must. This will be a straight line, a solid line. How it ends, since one employee can only be in one department, it's going to be a straight line that will enter into this place. But this one, since it's one department, will take more than one employee. Like accounting department, one accounting department, you have, it's not one employee you have inside now. You have more than one. So this one is going to be a crop foot that is going to go inside here. So let's see how it looks like here. So that's why you have this dotted line. This dotted line means that it's not all, like for example, accounting department. I am in IT department. So if I say accounting department is responsible for Kunle, that means I'm lying. Why? Because it's not. So the best thing you do is may, it's not must. But when you are looking at it from the other side, all employee must work in a department, a tick line. That's optionality. Cardinality, now let's look at cardinality means how it meets at this point. So departments, commercial departments may have multiple employees. Employee will work in a single department. The same thing applies to this one. Employee, if you're an employee, you must have a tick line job. A job, BI job, may belong to a single employee or multiple employees. Do we understand this ER diagram? I want us to unmute. Does it make sense?
Yes,
Yes,
I think it does.
Okay.
Thank you so much.
Yeah. If you have any question, please let me know. Okay. ER diagram convention. So how do you draw your ER diagram? You first draw a, let me see whether I can do something like that. I don't have there's a Lucid Charts application. There's Visual. You can use Microsoft Visual to do it. There are a couple of applications, but I don't have any of those applications now. I have to use this as an example. But the one I have, I can just play around with. It's this. So it's a round edged triangle that I use for entity. So each of the entity, for example, we have the employee entity. We have another entity. Sorry, I want to replicate this one. Please. Okay. So we talked about department entity. Parts. And the last one we talked about employee department, and which other one did we were we looking at? Job. So this is how you represent your entity. But if you want to further represent the columns, it now becomes something like this. So you have like this guy. So you have something like this. So on top of it, you have your entity name. And under it, you have your column names. So we are going to see how they link them together now. Okay. So we said drawing an entity diagram convention. We said entity as represented with soft box. These are the soft box. Said the entity name goes in the soft box. The entity name is always singular. So you don't write employees, it's always singular. It's not that it's, if you write employees, it won't work when you are writing the script or something, no. But it's just a normal standard. It's just like, for example, the example I want to use is you spoiled English for us, so I can't use it again. Before you use for a man, you use he. You can't use they for a single person, but now they use they for a single person. That's just the same way entity works. Entity is usually singular. So we said after you've created the softbox, underneath it, you put the hash sign to represent the unique identifier. You put asterisks to represent the other columns, and you use the circle to represent the optional, the one that can take null value. So it's not all employees that have commission. So for example, those people in marketing might have commission, those people in other departments might not have commission. So in such, when you are designing the entity diagram for such, you are going to make commission the 0 sign, you are going to put it there, the circle sign. But for the other ones that you must put a value, you put, it's going to be asterisk. For the one that is the unique identifier, you put your hash. So the same thing with all these ones. So we are building up on it bit by bit. So let's move to the next level. So let's now connect it. So as I told you, relationship is not a standard that it must be worked in. You might say an employee, well, we can give the relationship another name. An employee, can somebody help me? Yeah? Belongs to a department. A department is responsible for an employee. A department houses the employee. The relationship can be anything. So let's now talk about the cardinality and the optionality. Optionality first. So optionality is represented by this line. If it's a must, it will be a tick line. If it's a may, it's going to be a dotted line. So each one of them starts halfway. They start and end halfway. Talking about optionality, I'll talk about cardinality. So forget about this scroll leg. Forget about this dot first. Let's talk about the line. So if you are an employee of a company, you must have a department, Abby. So that's must, tick line. A department, commercial department, may have an employee, a particular employee. So you don't look at it as an entity. You look at it, when you are talking about relationship, you look at it as an instance. So for example, when I want to look at this relationship, you say Kunle is not employee. You say Kunle, who is an employee? Kunle must be in a department. Okay, let's now look at it from the other way around, now from department. Commercial department must, can we say commercial department must house everybody? No.
No.
We say may. Why? Because there are other departments. So that's how you get this tick line and dotted line. So let's now look at the cardinality now. Kunle, my cardinality, the cardinality of the instance coming here will be shown here. The cardinality of this one will be shown here. So Kunle, one Kunle can only be in one department. One, when it's one, it's a dash, single toe. Let's now look at commercial department. Is it one person that will be in commercial department? Please, I need response.
No.
No.
So many. When it's many, you have this scroll leg. So let's look at it. Let's look at employee to job now. So if you are called an employee, Olakunle must have a job before you can be called an employee. Am I right? But BI job, it's not compulsory that everybody must be a BI analyst. You understand? So it's going to be a may from job. So that's the optionality. So let's talk about the cardinality now. Remember, cardinality for the one on the left is shown on the right. The cardinality for the one on the right is shown on the left. So one employee who is only will have only one job. But one job description, BI, may be owned by many people, BI departments. Do you understand? Like 5 or 6 or 7 of them might be in that particular. And so that's how you draw your ER diagram. Do we understand it now?
Yes.
Yes, okay.
Yes,
The
sir.
reason why I'm asking is because we are going to do a project after this class. Okay, so let's move on. I think I've explained everything on that ER diagram. So they just, everything that you are meant to know here, that's what I've tried to explain. Thick line, solid line for most, dotted line for me, department, a single department, that's so it's a little bit confusing if you don't narrow it down to an instance. So whenever you want to do this one, don't look at it as an entity, look at it as an instance. Because you'll be the employee, there are many employees here now. This one too should be many. No. Just look at one employee, name an instance within that particular entity. That's what will make you to see how the relationship is. Do you understand? So we say employee now, name Kunle as an employee. Can Kunle be in more than one department? No, one department. So it's going to end up as a single dot. But department, social department, commercial department, it will have so many of them, cardinality. And looking at optionality now, Kunle, before you can be called an employee, you must be in a department. You can't just be a low ranger. Department, you can be a department and you will not have all the employee in one single department. So you have is a me. So that's what they explain in all this place, but I've tried to explain. So that's why they use each instance, each employee in entity one must solid line. That's what they are trying to explain. Walk in, that's the relationship. The department in a single department, that's the cardinality is dot one line. So let's look at it from the other side now. Each department may be responsible for one or more employee. So they will now merge the two together under here. They will now go halfway. That's what I just explained. Is it clear?
Yes.
Do we have anything that you want me to explain? So it's easier when you are talking about 2 tables, 3 tables, 4 tables, but in a huge organization, you have thousands of tables. So how do you go about that? How do you create relationships for that, for those ones? We make use of what we call the matrix. So how do we do it? I'll just go into it straight up. I talked about it last week, but I'll just talk about it again. So we said, we just list all the entity on the left and on the right. And we cross in between will just be a repetition of travel. So travel is still travel. So it cancels out. Country is still country here. Landmark is still landmark. But for other boxes that are white, those are the ones that we can create relationships. So let's see how we give it relationship. So I told you relationship names, you can call it anything. Travelers visit a country. We can say travelers go to a country. Go to can be relationship. The name doesn't really matter. But just put a name that makes a little bit of sense. Okay. Travelers have seen landmark. So we have created, that's how you create a relationship using your matrix diagram. And matrix diagram is usually used when you have multiple entities, and it's very simple. Okay, so and that's it. So you already know this one is related to this one, so there will be a relationship. So let's pick one traveler now. Let's see. One single traveler here can go to one or many countries. And can you see that it's dotted? May. So I might say I want to go to London, I might not want to go to London. May. It's not a must. Do you understand? That's why it's dotted. So let's look at it from the other side now, from country to traveler now. So this country may be visited by a traveler. So it's not compulsory you visit all countries. So it's a may. But many travelers can. So this country is many of these countries, as in one single country may be visited by many travelers, and many travelers may, a single traveler may visit many countries. But this kind of relationship, later on we are going to see how we can break it down, because we shouldn't have a many-to-many relationship. When we have a many-to-many relationship, the relationship will be converted into an entity. We are going to see how we do that later on. So let's see this one. A country like Nigeria is located, is a location for, maybe a location for a landmark, Aso Rock. Aso Rock cannot be in Nigeria and in Ghana. Aso Rock must be in one country. Although there are some situations, Lagos can be in London, and Lagos can be in America, Lagos can be in Nigeria. There are situations like that, but it depends on the scenario. But this time around, we are just looking at things that it depends on how you look at it. That's what is going to determine how you are going to draw this relationship. So a landmark may be seen by a traveler. A traveler may have seen a landmark. So many travelers, one or many travelers can see. This landmark may be seen by many travelers. That's why we have this cross sign. So if you have, this is like many-to-many kind of relationship. So that is how you design your crawl. That's how you design your multiple ER diagram, which is, the method is called matrix diagram. Okay. I have 30 minutes more. So let's talk about super types and subtypes. And after that, I will advise that we go into SQL proper. Okay, so what are super types? What are subtypes? Super types are like parents, class, while subtype is subclass. So father, super type. Children, firstborn, secondborn, subtypes. So we have examples like that when we talk about entities. So let's see examples of entities. That's, when we are talking about different kinds of accounts the other time, this is where things like that will fall into. And how do we go about them? So for example, payment for an organization, that payment is an entity. So which kind of payment? Is it cash? Is it check? Is it credit card? So these are entities, but they are all types of payment. So how do you evaluate entities? How do you look at the entities, whether you are going to pull it out and let it stand on its own, or you can make it a sub-entity? That's what we want to talk about now. So we saw this example that I just explained. We said, should we create a single payment entity or 3 separate entities, this one, this one, this one. What happens in future if you introduce the 4th method of payment? So this is what we call this one inexhaustive. Inexhaustive means that you might have multiple of it later on. You can all the options cannot be exhausted. So in cases like this, what do you do? You group the new ones that may come in future. You just make them orders. That's one way to approach this one. To approach this one. So, and for the attributes, because the attributes, almost all the attributes are similar, except for if it's cash, it will be a legal tender. If it's check, it's going to be a check format. But all of them, they are payments. They are attached to a particular transaction. Every other attribute is same, except for how the format of the payment. So in such cases, you still use it as a sub entity. Well, let's look at another kind of sub division in entities. This one, for example, animal, we have vertebrate, we have invertebrate. In cases like this, it's exhaustive. You can't have more than all animals. It's either you are good under vertebrate or invertebrate. Later on, scientists can discover, but for now, this is like the standard. It can't go outside this one. Okay, so this one is called exhaustive. So let's see, how do we approach this one? We said inheriting any attribute for the we said this subclass, it inherits all the attributes of the superclass, inherits all relationship of the superclass. It usually has its own attributes or relationship, is drawn within the superclass. We said it's never exists alone. Subtypes, they can never exist alone. There will always be the other type. It's either it's vertebrate or invertebrate. Okay. So how do we design such using our ER diagram? So it's just the same thing, but this time around, we have a common name. All these are different kinds of exam: midterm exam, final exam, and quiz. So all of them will have an ID, description, wave, the dates, and the grade written for the component. But for midterm, it will have its own specific attribute, which is grade for oral presentation. For final one, it has extra point for optional paper, and the last one is quiz. So all of them have the same relationship. It's just the same relationship that a student has with exam. It has the same relationship. All student takes exam. Exam is taken by all students. It's the same relationship, but because it's a subtype, it has its own circular circle edge rectangle, which talks about the specific kind of exam. So this is how you design data model. This is how you do a data model when you have a subclass within within a particular model. Okay. So I think that's what they explained in all these ones. So I've explained one can be exhaustive, one can be mutually exhaustive, exclusive. I think I've explained that. So how do you go about it if it's not exhaustive? You just put others. So any other one that does not fall into this category, it falls into others. I think I've explained that. Okay, I don't want to take so much of our time. Let's go to we'll finish up data modeling next week, but let's go into data programming. So far, do you have any question? I have 30 minutes more. Do you have any question on what we've talked about? Or is still making sense? Or is not making sense somewhere? you want me to clarify? Anybody?
That instance where you were making the instance with student takes exam, all student takes exam.
Yeah.
Exams is taken by student. I was looking
Yes.
at it that is it that arrow, is it for one student can take more than one exams?
Yes, it's the same principle that we use for all of them.
Okay.
Okay, for example, let's look at it. Let's look at it. Where is it? Okay.
Yeah. Yes. Yeah.
So, yeah. So one student, we take a physics 001 exam.
Okay.
Do you understand? So one student, we take, oh, sorry, this time around, we are looking at the student 2 exams because we are looking at multiple types. So it's going to be one student, we take one or more exams.
Okay.
That's why we have this score for it. But a particular exam, 001, which is this one that has this grade, that has this weighted time, all those things, identifier, is taken by one student. So this model is straightforward and simple based on, okay, what do they want to design? That's what is going to determine what you are going to have here, whether it's going to be a Crawford, whether it's going to be this one. Okay. But in this scenario, what we want to see is, okay, a particular student, each student, we do multiple exams. One particular exam that has all this, you know, it has the grade of the student. You can't give it to any student. It must belong to one student. Do you understand? Okay. So that's why we have one here. Okay. Any other question before we go on? Okay, no question then. Database programming with SQL. So quickly, we want to look at our objective. One, we want to talk about what application softwares are, what system softwares are, and give examples. Two, we are going to log on into the application we logged on to last week. I have 27 minutes. We are going to write simple SQL statements. And lastly, we are going to, under this objective, we are going to see how we display columns and a set of specific columns. So here, I'm going to make it much more practical. I will prefer doing some typing and some other things. I'm just going to summarize this. So what are application programs? So the story here talks about in the olden days, when you are using a computer, is machine language that people usually use directly. You don't click, you don't have the GUIs. So application program is what you use that is being built to interact with the system so that you can just do clicking and you see the thing working. So that's what an application program is all about. Okay, so application program, we said, is different from system software. Under system software, we said system software, they are more or less like they are connected to the system directly. For example, the operating system, compiler, for those of us that we do programming, system utilities, all these ones, the way they work is they connect using low-level language, which is our binary. While the application program, they relate with the operational operation system or the system program system software. So let me simplify it a little bit. Microsoft Office is an example of operating system. Office. Unix. Microsoft Windows, sorry. Office is application, I'm sorry. Yes. Microsoft Windows is operating system. Yes. So it's the one that makes this hardware whatsoever you do to this on the system is the one that interprets it to the hardware. And whatsoever you do to the hardware is the one that brings it out. It's like the intermediary. They call it the system software. But on top of the system software, we have application software. So application software, an example is Microsoft Office, which this one relates with the system software, and the system software relates with the hardware. So why do we need to talk about all these stories? Is because
sorry, I have a question.
Yes, please.
So just to further understand what you're saying, if we relate it to phones now, will it be
Android,
an Android and then Google Maps being the application program?
Correct. Android is the system
operating software. Okay, thank you.
While Google Map is, thank you so much for that example. Yeah. Okay. So I think I just want to jump quickly. So quickly, let's open up. Can we say remember this place? Let me try to log on. Yeah. Can we still remember our password?
Yes.
Yes, I need the result. Can we log in, everybody? A file was sent to you. That file, FOL something on email. Please, can you quickly download it also? And I want you to know the location where you downloaded it to, because we are going to use it. So please try to log on. I'm logging on to my own.
Don't forget.
Remember, I told you to store your password. It will be very difficult to get your password. If the
application is what? Let me find it on my system.
No, it's a web application. So just put this into your browser.
Okay. Can you please send the link to us again?
Okay, I'll do that. Done. So after logging in, you are going to see what I'm seeing on my screen.
What's the workspace?
I'm coming, 1 second.
Because I'm getting error.
Okay, can you share your screen? Let me see what you are doing to see whether.
Okay. Can you see my screen?
Not yet. But it's coming up. Okay, so the workspace is the same name as the schema name. Just this one that ends with 13, just copy it. Yes, I pasted it there. So your workspace is the same thing as. Why don't you click remind workspace name? Okay, you are good.
How do you create an account, or was it created from backend or something?
Yes. It's a standard Oracle teaching lab.
Okay, I don't have a username and password.
Okay, Robody.
Okay.
What was the last one you gave out?
I gave to Eunice 23, and I gave to, let me check again. I gave Adetayo 20. I just want to so that okay. Adetayo 23, the Eunice 24. So what's the person's name now?
Sorry, what's your name, please?
Damilola.
Damilola will be 25.
Let me just give you the. That will be your username and your workspace name. Your password, first-time password. I'm going to share your first-time password. It's going to tell you to. Please, can you share your screen so that you won't make mistake? You just get it once, so that won't delay the class. Okay, so your workspace name is still the same, GB FOL that you copied. Yep. So click this remember workspace and yes, so I remember. Your password for the first time will be that password I shared with the question mark or something. I don't know what was that back. Okay, exclamation mark. Copy the exclamation mark. It starts with small letter Z to the question mark, to the exclamation mark. Please.
Can you help us also, because of the three people I just tried to log in now, that GB stuff that I said we cannot type ourselves, that we just have to copy it? Or should I send it to them on what?
Okay, let me just send it to everybody, but you change, I'm sending Damilola's on to you. You change the 25 to your own number.
Okay.
Your own is 23. Yeah. So if your own is, your number is 23, your number is 50, your number is whatever your number is.
Well, the number is 2.
Your number is 2, is 02. So for somebody that his number is 2, this is how it's going to look like. Please ask, we just started the class, so ask any question.
Sorry, you sent 3 files. Which one do you want us to download?
Just download it on your system.
I think it's coming as FOL_DD, FOL_DP, SQL schema.
SQL schema. The other ones are they are slide. So FOL_DB is database design. That's the one that we just did now. The other one is FOL_DP. That's database programming. That's the one we just started now. Please, if you're having any issue, don't try to do it yourself. If you're having
I'm sorry, I didn't get any files. I didn't receive any files in my email. I only got links to the meeting and the previous class.
I've sent the file to you. No. Check your email.
Okay.
I want to reset my password.
That's big work. Yes, that's.
I wanted to try one. I've not tried it too. I thought I wrote it somewhere. I'm looking for it.
Please look for it. It will take a while. It's going to eat all the time that we have.
Oh, okay, no problem.
I can do it for you after the class, or not now.
No problem.
Please, let's keep our passwords.
I'm sorry, you said you sent Rachel, you said you sent something.
A file. Yeah. On the 3rd of
as an email?
October. Yep, on the 3rd of October.
Check that, sorry.
Did you receive it so that I will just send my personal mail now? Okay, you receive it now. Jeremiah@gmail.com, 3rd of October, 8:25.
So this is the content of the file.
Okay,
can you see my screen?
I've seen it. Yeah.
So let's download that file. So this file contains.
Okay, sir, can we share it in the so that we can move ahead as fast in the link?
Okay.
Yeah, I just did. I just dropped it into the main chat.
Okay.
Okay. Thanks. So this script has it has so many scripts, how to delete a table, how to do so many things, and we inserted into the table. But later on, we understand all these jargons there. They are very simple. But we want to just input it into our database so that we can have data to work with. That's why we want to do that now. So am I waiting for anybody? If no response, that means I'm not waiting for everybody. We are all here then. So in our application express, that Oracle application express, the web application is just like a full database. RDBM is Relational Database Management System. Also, you can download it. It's very, very heavy if you download it. That's why whenever we are doing trainings like this, Oracle sets up a server for us to do it. And it has all the capability of installing a full database into your on your system. Okay, so we have what we call the object under the Application Express, Oracle Application Express. We have the app builder, which we use in creating dashboards, forms, and things like that. We have the SQL workshop, which we have our object browser, our SQL commands. This way we write our SQL command. We have this where we upload our scripts. That's where we are going to go to now. This where we do utility, maintenance, settings, and things like that. And this is other services relating to cloud. We have team development. Under team development, use it for majorly for building. And we have where we keep milestone features, to-do lists, and things like that. These are usually to manage how work is being done. And the last point is the app gallery. We have different apps which we can embed into this one. Okay, but this is where we are going to, this course is going to, we are not going to go outside of this space within this course. So we click on our SQL scripts. Please, can we click on SQL scripts?
Hello. Yeah. Now I'll never finish. It's not 3.
Okay,
So can you copy that old password that you copied for us that time?
Okay. I send the old password again.
Yes, it's not here. Okay, let me see. I think you sent it to me. Let me just see whether I can just copy it.
No, I can do that. That's not a big deal. It's here already. So
okay.
It's here now.
Okay.
Are we together? Can I go on? No response.
Yes,
that
please.
means,
Yes,
that means
please.
I can go on.
Yes,
so
yes,
if you are here now, you come to upload. We want to upload that script that you just downloaded. Please unzip that script, that file, unzip it. So you click upload. From upload, choose file. You now go to that location where the file this one, you click on it. Are we together? If I'm too fast, please let me know now. I don't want us to draw everybody backwards.
Yes, please. Yes, you are too fast. Just hold on while we unzip the file.
Please unzip the file. Hold on, let me go back. So we start from here.
I couldn't access my platform again, so I'm just looking.
Last week I talked about that password thing.
I thought I wrote it somewhere. I don't know where I wrote it. The notepad I saved, the password is not there, just this other word and the link. So I thought the password I saved it.
Okay, no problem. After the class, we won't really go very far today because I want us to take it just to digest what we have done. But from next week, we are going to go very, very fast.
Sorry, I have a different interface appearing on my screen.
Please share your screen.
Okay, I'll just take that.
Share your screen.
Can you see the screen now?
Yes. So you click on the third item, SQL. No. Here, SQL script. Yes.
Okay.
Yeah, you are there now.
Okay,
so you click on upload.
Okay.
How do you unzip?
Unzip, just right click, unzip.
It's not giving me the option.
Okay, hold on 1 second. Can you share your screen?
Well, others are not talking. Everybody is getting this?
We are good. We're just waiting for others.
Okay.
Fantastic.
Can you see my screen?
Yes, extract all. The second one. Yeah. Okay. So just extract. Yeah. Yeah. Just open. Copy the address on top. The address here. No, up. Yeah. Copy. Yeah. Perfect. So you go back. So we are going to continue from your screen.
From my screen?
Okay. Yes. Is that okay?
Okay, that's fine.
Okay.
So I'll go back to, let me bring this down there.
The browser, yes.
That's why it was confusing. The voice was masculine, but the name is Evelyn, so I was wondering.
No worries, my wife's listening.
Okay. Or should I continue?
Continue, please.
Okay.
Yeah,
You stop sharing. No. Okay, so can you all see my screen?
Yes.
Yes.
Okay, so upload. You click on upload. Choose file. I may have already navigated to that directory, but if you haven't, what you copied, you just put the address here and you click enter. It takes you to this page. So you click on the SQL schema.sql. Are we together?
Yes.
So you click on it, you click open. Please don't be too fast. If you make mistake, it's going to throw everybody backwards at this point. Just follow.
Sorry, please come again. I think I'm lost.
Okay. Are you here?
Yes, upload.
So you click on upload.
Mm-hmm.
You click on choose file. The location where that file that you downloaded and you unzipped. You look for that file.
Do you know where it is? That's the
Or
question.
you would like to share your screen?
Yes, I know where it is.
Please share your screen. Please share your screen so that we'll be together. Are you ready to share your screen? Yeah.
Yes.
Okay. I have 7 minutes. Can I do extra 10 minutes? Can I do extra 10 minutes today?
I'm sharing my screen. Can you see my screen?
Yeah, we can
choose
see it.
file. Nobody's answering me. I said, can
No,
I do
no.
I can't do extra 10 minutes.
No.
Let's end it here. Let's end it here.
Extra 10 minutes.
Let's end it here. So I will not lose so much.
Okay, no problem. Choose
please.
file now.
Okay.
Are we all together?
Uh-huh.
That location, where can you find the file? Where you kept that?
I cannot find it. Wait.
Where did you download it?
I don't know from
Maybe try the downloads.
Click download, is there?
Yeah, click download. Just click down.
She's already in download. So
Okay, scroll down. Scroll down.
Click date modifier.
Click date modifier to arrange.
Just
No.
in the middle. In the middle.
Come down. Yeah, that place.
Click that place.
It should be the last one or the first one.
Yeah, in 2021 now.
It's not here.
That means you didn't download it. Can you quickly go back to the chat file and download it?
I downloaded it though.
No, don't worry. Let's do that again.
You picked the wrong place. You see, you went to the wrong place.
Just go back to the chat and download.
How do I get to the chat? Okay.
Your
Somebody
chat.
drop it in the chat. That was showing
it, right?
The Zoom chat. Yeah, the Zoom chat.
The Zoom chat. The one
Can
showing
you see my screen?
Yes, I can see your screen.
It's already downloaded. It's telling me click to open.
Okay, I can't. You didn't share your whole screen. You only shared that place, so I can't see that part.
I think you are using two screens, right?
I'm using my laptop.
And there's no problem. Just you are going to reshare. Stop sharing first. Okay. Just click on share first. After clicking on share, you look down to your right. You see share all, one blue button to your right, down.
Share.
It's share all or something.
I'm not saying share all.
It's share. Only share is blue button. Just share.
Yes.
Oh yeah, click on that one. Good. Yeah, we can see your screen now. So
So it's on your desktop, it's not on your download. You can
double
see
click it.
this
Double click,
PC.
double click this FOL training.
Tells me select all.
No, I can't see what you have done. Just double click it first. I want you to open it.
I think it's hanging.
I want you to copy this address, just like, yes, just copy the address.
Okay,
Click on where, okay.
It's on desktop PC.
Yeah.
Okay, great, perfect. Oh yeah, go back to that place and let's locate it. Okay, yeah. Choose file, good.
Desktop, click
Desktop. Yeah. Yeah, that's it. Yeah,
click again.
open it again. Yeah,
So double click on that one, double click straight away on the SQL schema.
The last one.
SQL schema, double click.
Yeah, perfect. Okay, hold on. Don't do anything yet. So all of us is going to clash because it has a central database. So your schema name, let it be FOL underscore your number. If your number is 01, let it be SQL underscore 01. If your number is 02, let it be SQL FOL underscore 02.
That for the script name?
Yeah, for script name, yes.
Underscore S before the name.
Yeah, underscore S before your number. 01, 02, 03, 04. Do we get what I'm saying? So what's your number?
13.
Yes. Yeah, FOL.
FOL.
Yes, underscore. Yes. Capital S.
S13.
Yeah, your number is 13, am I right?
Yes.
Okay. Upload. So you'll be our teacher. Yes, please. Just hold on, just click it once. You have clicked it twice. You uploaded twice. Okay, you do something, just check one on the left-hand side. Check one and click on delete on top. Delete checked. Yes, it's just one you need to upload. Okay. So check the other one now. So you can, on your right-hand side, don't delete. Hold on. On your right-hand side, you can see a button that looks like play button under run, right-hand side. Below create. Below create. No. Right-hand side.
Under create, there is run. Then that play button.
That button. Okay, stop sharing. Let me help.
I don't know. I'm not seeing it.
You're almost there now.
Don't worry. Let me share so that we won't take our time. Okay. So for those of us that have not done it, upload, choose file as just double click. It comes here. My own is FOL because I'm using C01.
FOL underscore S. Okay.
Yeah. I click on upload. So it uploads it. I check it. I come to this side. Can you see?
Okay. The screen was blocking that part. So that's like
okay. Can we see everybody? If you are not here, please let me know. I have 1 minute. And you said I can't use 10 minutes extra.
That's round
okay.
up.
Please go on, sir.
Round up.
Okay, I'll try to round up now.
No, sir, you can't dictate. Mr. Gwe, you can't dictate. So everybody's, no of us are in this class. So
no, I'm not holding him back. I said I should round up. That's it should go ahead.
No problem. Don't let us do that. That is taking time. Okay, run now. You click on run now. Yeah. So when you click on run now, you see the arrow will be turning. Yeah, it gives you something like this. So it tells you all the action that has been done. So it tells you the statement that was run. It tells you how many was successful, how many failed. Good. If you are not where I am, let me know, please.
My dear sir.
Okay. If nobody is talking, that means we are in the right place. Okay. So you know what to do. So let's now go into the place where we write our query. So we'll click up here. We go back to, let me show you the object browser first before we go to query command, SQL command. So click on, can we see where I am? You go up here, click on object browser. On your object browser, you see all the table names that was inside that script that we just created now. We have countries, we have departments, we have DCDS, we have department clients, we have these are the tables in one word. These are the tables that we have. So let's now write our first SQL statement against the country, and that's where we are going to stop today. So we come here, we click on SQL command. So it gives you an interface like this.
Sorry, please slow down.
Okay, just come up here. You come to SQL command. Are we together now? Are you seeing what I'm saying?
Yes, sir.
Okay. If anybody is not seeing it, please let me know.
Right.
Hello?
Yeah,
I'm waiting for you, sir.
Sorry, I think my internet went off. I don't know what happened. Okay. Yeah. Can you see my screen now?
Yes.
Yes.
So English language, if you want to say, go and get me this cup, you are saying, or you are telling somebody to go and get you this cup. In SQL, if you want to retrieve something from a database, you say select. So the next question is, what should I select? Go and bring. That's what select means. Go and bring, select. So what should I select? Should I select a specific column, or should I select all the columns? So if you tell me to select all the columns, where should I get it from? Is it from the kitchen? Is it from the bedroom? From the table name. So that's the syntax for retrieving something from the database. I'm going to explain more next week, but I just want to let us see what this SQL is all about. So can we type select? If you want to get all the columns, you use Shift-8 star. From where do you want to get it from? Let's do countries. You know, I showed you all the table names that we have. And I can see that we have a table called countries. That's why I can say, okay, we can select all the columns, the records inside the table called countries. So it's very simple. The syntax is always select something from something. So select maybe all the columns, select specific columns. We are going to talk about how we can do that next week from the name of the table or the name of the object. Are we all there?
Yes.
So you highlight and you go here. Can you see it? Run. You click on run. Underneath it, you see your results. Country ID, CA, the name of the country.
Sorry,
Canada.
can you go back a bit to where you clicked on run?
So you just highlight, you click on run. And that's all. You see this one pop up.
Sorry, one question. Why do we have to highlight though?
Okay, the reason why we need to highlight is later on when we have multiple queries within the table, the way it knows that is this one that you want to run. Let me see which other table do we have here. Let me see. I think we have a table called jobs. Let me see. Yeah, we have a table called jobs. Okay, so if I want to know whether it's this one I should run or this one I should run, I just highlight the one I should run.
Can we run two at the same time? I know it might be
Yes,
stupid.
we can run two at the same time, yes.
Okay.
Can run two at the same time. And we can even have multiple. Later on, we'll talk about how we can do that. Oh, it's giving me. Normally, other IDs, you should be able to run more than two. So what it will just do is it will give you one on top and the other one under. But I don't think whether this one, no, this one doesn't have the intelligence to do that. Other IDs can do it. So you have to run one. So let's call it a very good day from here. I use extra 7 minutes. So sorry for wasting your time.
Yeah, no, it's not.
Thank you very much, sir.
Thank you, everybody.
Thank you.
We'll see next week.
Thank you very much.
Yeah.
Thank
you very
Thank you
much,
so much.
and thank you for everyone.
Thank you so much.
And don't forget your password next time.
Okay, I hope I'm able to go out of this now so that I will not forget it.
Okay.
No, for the people that have forgotten their password, just stay behind.
Okay, sir.
We'll stop recording. I will try to fix your password before I go.
Thank you, sir.